人。有乳腺癌遗传史、做过胸部填充术的女性，也建议进行乳腺磁共振检查。80%的活检结果都是良性的，所以不用恐慌。最重要的是，你能知道有很多选择，可以来确定你的乳房是否健康。对于拥有致密型乳房的亚洲人群体而言，乳腺磁共振检查尤为重要以及精准。虽然费用会高一些，但可以发现更早期的病变，让女性更放心。分享花房社小程序，让你身边的朋友和你一起了解自己的乳房。定期自检可以帮你尽早发现异常。30岁以上的女性建议定期进行超声检查。如果你觉得乳房有变化，请随时就医。如果医生在触诊以及超声检查后，必要情况可进行乳腺磁共振检查或钼靶 X 射线检查。如果检查结果无异样，即可放心继续自检。经仪器检查有高度可疑病灶表现的，需要进行活检确认。有乳腺癌遗传史、做过胸部填充术的女性，也建议进行乳腺磁共振检查。80%的活检结果都是良性的，所以不用恐慌。最重要的是，你能知道有很多选择，可以来确定你的乳房是否健康。对于拥有致密型乳房的亚洲人群体而言，乳腺磁共振检查尤为重要以及精准。虽然费用会高一些，但可以发现更早期的病变，让你更放心。分享花房社小程序，让你身边的朋友和你一起了解自己的乳房。定期自检可以帮你尽早发现异常。30岁以上的女性建议定期进行超声检查。如果你觉得乳房有变化，请随时就医。如果医生在触诊以及超声检查后，必要情况可进行乳腺磁共振检查或钼靶 X 射线检查。如果检查结果无异样，即可放心继续自检。经仪器检查有高度可疑病灶表现的，需要进行活检确认。有乳腺癌遗传史、做过胸部填充术的女性，也建议进行乳腺磁共振检查。80%的活检结果都是良性的，所以不用恐慌。最重要的是，你能知道有很多选择，可以来确定你的乳房是否健康。对于拥有致密型乳房的亚洲人群体而言，乳腺磁共振检查尤为重要以及精准。虽然费用会高一些，但可以发现更早期的病变，让你更放心。分享花房社小程序，让你身边的朋友。
Now we have 1 minute to begin our lecture.
Bingo. Great. Oh, Dr. Young, great! You came home on time.
Yes, just back from the meeting. Yes, just on time. Yeah.
Excellent. That's great. Thank you.
You're welcome.
哦，洪轩也进来了。嗨，洪轩你好。
Hello，我们正在转播。
哦呀，哦，谢谢。哎，安利也进来了。OK， 洪校长，我们可以开始。冯校长，我们可以开始了吗？9点了。
Okay.
Okay, great.
Should we start?
Please.
Got a quick question. I've got a toolbar at the bottom of my screen that could cover up some of the slides. Does anybody have any idea how to get rid of the toolbar?
Could you please use the keyboard page up and page down to try to change the
Okay.
slide?
Yeah, it's not, there we go. Okay.
Okay, good.
Okay.
It looks good to us.
Okay, all right.
Good morning, good afternoon, good evening, as the case may be. My name is Dashuan Feng. I am the board chairman of Aurora Advisory Board. This is a tremendous honor for me to kick off the second of the Aurora's lecture series in honor of Paul Lauterbur, the scientist who made magnetic resonance imaging, or MRI, available to humanity. For that discovery, he and Sir Peter Mansfield of the University of Nottingham in the United Kingdom were bestowed the highest scientific accolade, the 2003 Nobel Prize in Physiology and Medicine. Ladies and gentlemen, the ultimate aim of any corporation should be to do well while do good. From the very beginning, Aurora is a company who aims to battle one of the deadliest diseases challenging humanity, especially the females, and that until a cure can be found, the only way to significantly reduce the mortality rate from this disease is to detect it as soon as possible, maybe even sooner than that. To do that, ladies and gentlemen, leveraging the extreme sensitivity of detection from MRI appears to be the only way to reach this goal. To this end, in Aurora's more than 20 years of operation, utilizing MRI first as a diagnostic technology, and now more and more moving aggressively towards a screening technology, is its never-ending modus operandi. Friends, with the above, obviously, Aurora not only has the mission to carry out the comprehensive R&D to reach the screening goal, it also has the solemn responsibility to inform the public worldwide in a colloquial manner what MRI scientifically is and how it could become a screening tool for humanity. After all, as the great Einstein said, make it simple, not simpler. It is for this reason that we have initiated the Lauterbur Lecture Series. The fact that our Chief Medical Officer, Dr. Stephen Harms, is a disciple of Dr. Paul Lauterbur at the fledgling stage of the development of the MRI made it natural for us to invite him to kick off this lecture series to honor his teacher. Today, we are also truly excited that Dr. Alan Hollingsworth, the Vice President of Aurora, in charge of breast screening program, will be delivering the second Lauterbur lecture. Let me also take this opportunity to introduce to everyone of our pivotal supporters of the event, the Gift to Asia. With the above preamble, I am both pleased and honored to introduce to all today the chairman of Gift to Asia, Mr. George Syed, to say a few words of support of our effort. In the political, corporate, and education landscapes, George's footsteps are both broad and deep. For example, he was the commissioner for the City and County of San Francisco's Social Services Department under Mayor Dianne Feinstein. He also had served for 15 years on the advisory board of Stanford University's Institute for International Studies. In the corporate landscape, he has experiences serving as chairman, CEO, CFO, and treasury of some of the leading corporations, George is known to be as strategic in his mindset as he is visionary. So without ado, with this, may I introduce to you George. George, the floor or the screen is yours. Thank you.
Well, thank you, Dr. Feng Dashen, for that kind introduction. And greetings from San Francisco, ladies and gentlemen. Thank you also to Aurora Healthcare for allowing me to be part of this event and for offering Give to Asia the opportunity to support Aurora's efforts to bring more effective breast cancer detection to needy communities in Asia. Before introducing Olivia, please allow me to provide some background on Give to Asia for those of you who may not know us. Give to Asia was founded 21 years ago. As a non-for-profit organization, we fund charitable projects in over 20 countries in the Asia-Pacific region. In 2021, we provided funding to nearly 450 projects, totaling 65 million US dollars for charities across Asia. We are true believers that social services, including health services, must be localized to meet a community's special needs. Our tagline is local knowledge counts. That's why we have local presence everywhere we engage in charitable activity. For example, Give to Asia's China representative office in Beijing is staffed with 10 nonprofit professionals who work to build partnerships with China-based charities and institutions. In Hong Kong, our affiliate, Give to Asia Foundation Limited, is not only building local programs, but also working with private philanthropy, going out to other parts of Asia and the world. The foundation is chaired by Dr. Raymond Leong, who is also in today's audience. In fact, it was Raymond who brought Olivia Chung's efforts at Aurora to Give to Asia's attention. Raymond, with his technology background and vast business and management experience in Hong Kong, China, Japan, and the US, recognized the needs of women in the workforce and in society. So thank you, Raymond Leong, for making this introduction. Give to Asia also has staff in New Delhi and Bangalore to serve and identify partners and manage grants in India, which has historically been our second most active market after China. I should also note that we recently partnered with the King Baudouin Foundation in Brussels, Belgium, so that we may better tap charitable investments from across Europe and Canada, in addition to our traditional funding sources in the United States. So while our program focus is very local, we do see ourselves as part of a truly global community of philanthropists. Give to Asia has some history supporting breast cancer detection, specifically in China. As early as 2008, Give to Asia partnered with the Avon Foundation for Women to help set up traditional breast screening centers in collaboration with the China Women's Development Foundation and the China Breast Cancer Foundation. These were the first breast cancer screening centers ever available in Deyang, a city of 3.5 million people in Sichuan province. More recently, during the height of the COVID-19 outbreak in Hubei province in early 2020, Give to Asia helped the China Women's Development Foundation to place ventilators in hospitals. Meanwhile, in Hong Kong, Give to Asia Foundation partnered with the Hong Kong Hospital Authority and helped facilitate the delivery of protective gear and care packages for nurses, doctors, and other medical staff during the pandemic. Given its roots in San Francisco and Silicon Valley, it's only natural that Give to Asia recognize the importance that technological advances can play and how these advances, when paired with local partnerships, can make important, sustainable improvements for a community. That's why we have funded early warning flood detection projects in India, the provision of mobile scanning devices for rural doctors in China, and improved farming technologies for rural communities in the Philippines. All of these can also be considered examples of risk mitigation strategies. And risk mitigation is a key part of Dr. Alan Hollingsworth's talk today. Give to Asia is excited about the MRI technology being developed by Aurora and its potential to reach underserved communities across China and elsewhere in Asia. Give to Asia's charitable mission and Aurora's efforts to commercialize the MRI technologies that you will hear about today are well aligned. Now, I would like to introduce Ms. Olivia Ho Chung, the CEO of Aurora Healthcare. I had the opportunity to meet Olivia for the first time in person last year. She's not only a wonderful humanitarian, but also a dynamic visionary. In addition to her impressive and persistent efforts to bring Aurora's MRI screening technology to market, Olivia served on the boards of several organizations that are world leaders in healthcare, including Tufts University School of Medicine, 2 NGOs affiliated with Harvard University School of Public Health and Massachusetts General Hospital, Hua Zhong University's Center for Biomedical Photonics, and Hainan University's International Advisory Board. Thank you, Olivia, for allowing Give to Asia to be part of Aurora's exciting project, which will benefit millions, if not billions, of women in Asia and around the world. I'll now hand the microphone over to Olivia so she can introduce today's lecturer, Dr. Alan Hollingsworth. Over to you, Olivia.
Thank you. Well, thank you, George, for your sharing, your great sharing about Give to Asia's tremendous contribution and your kind introduction of me. We count ourselves very blessed to have privilege to associate with extraordinary friends like all of you. And we thank also our colleagues from Give to Asia, US-China Health Summit, Beijing Love Book Cancer Foundation, China Pink Ribbon Foundation, and Hong Kong Cancer Foundation for their co-sponsoring of today's lecture. It is my greatest honor to introduce our speaker, Dr. Alan Hollingsworth. Alan is an esteemed breast surgeon. He received numerous awards, 11 to be exact, including American's Best Doctor in Cancer, and American's Top Doctor in the US, and Young Master Teacher, to name a few. Alan also co-lead NIH NCI research and clinical trial programs and published 45 papers and 7 books. I had the fortune to meet Alan 20 years ago when he and Dr. Becky Stowe Clinton came visit Aurora's breast MRI manufacture facility in Massachusetts in 2002, which resulted in the installation of the Aurora's breast MRI system at Oklahoma Mercy Hospital in 2003, right after we received our FDA approval. I vividly remember and was deeply moved by these 2 physicians' compassion to pursue clinical excellence for the benefits of their patients who suffer from breast cancer. We have the honor to call them both partners through our 20 years partnership to further our technology developments and clinical applications. Today, Alan will share with us his decades of experience helping and guiding patients in the US and worldwide how to best protect themselves to prevent dying from breast cancer. And without further delay, let's welcome Dr. Hollingsworth.
Hello, thank you, Olivia. I'm Dr. Alan Hollingsworth, and I am honored to present the second Lauterbur lecture. My title is From Mammography to MRI, the Evolution of Breast Cancer Screening. We are honoring Dr. Paul Lauterbur, as Olivia mentioned, as the chemist who shared the Nobel Prize in Physiology or Medicine in 2003, along with Peter Mansfield for their work, which made the development of magnetic resonance imaging possible in the clinic. There had been a long history of nuclear magnetic resonance dating back to 1937 with other Nobel Prizes awarded for the basic science, but it was moving it into the clinic that made the difference. In 2003, of interest, Dr. Raymond Damadian built the first body scanner and was not included in the Nobel Prize awarded, and that makes for interesting reading on the internet. Dr. Lauterbur, of course, was Dr. Harm's mentor, and Dr. Harm's founder of Aurora and inventor of rodeo MRI, but he did his postdoc at Stony Brook with Dr. Lauterbur. So when we started our program, and I call it a program because we treated this more than just another radiology machine, we Dr. Rebecca Stow Clinton took the lead on quality assurance, and we collected our data and monitored things very closely. And so we considered it a program, but Dr. Harm's influence on that was great. And so we like to brag that we are 2 degrees of separation from a Nobel Prize. Well, Dr. Harms gave the first lecture, and it was fascinating. And I learned that he had a feature story on CBS Nightly News in December 3rd, 1991. This is 10 years before MRI became available. And his work he was presenting at RSNA, and there was a big public response to this story, enthusiasm about MRI, because people were already getting the feeling that mammograms weren't enough. But I'd like to point out that during the research and development years of MRI, Dr. Harms was the only speaker who left the radiology world and would come over to our conferences in surgery and other specialties and deliver what's new in breast MRI. And that went on for many years. And I think we easily can refer to Dr. Harms as the father of breast MRI. So breast MRI had some unique challenges that delayed its introduction by about 15 years after we were already using it for the rest of the body. As with mammography, there was no normal, infinite number of patterns. It required contrast. The biopsy was difficult. What technique do we use? How do we go from unilateral to bilateral? And so and I give a history of how it emerged into the clinic there from 97 to 2003. And we were early adopters when we installed our unit in 2003. So my outline is epidemiology of cancer screening, true mammographic sensitivity, breast MRI sensitivity, and then who do we use MRI on. So indications for breast MRI, there are many, but I'm only going to focus on screening. Quick terminology for those that are not clinicians, DCIS is ductal carcinoma in situ, where the malignant cells are inside the duct, can grow along that duct. In fact, they can grow a good distance till as much as a third of the breast is involved, but if it hadn't invaded, it's still non-life threatening. Invasive cancer, the cells break through, form a mass seen on mammography, and this is where cells can access the bloodstream. And one other terminology that I'll refer to is cancer detection rate, or CDR, and this is the number of cancers detected per 1,000 screens. It's just a standard epidemiologic term. But it's important to know that these are highly dependent on whether the study is a prevalent screen, that's the first screen that reflects disease prevalence in a population, or an incidence screen, which are all the screens that follow that reflect annual disease incidence. And some will be a mixture of the two, high-risk populations, a lot of variables, but the important point is that no matter what the modality, it cannot find more cancers than are actually developing. So all long-term screening starts off with higher prevalence, then decreases to incidence, because people are always wondering, why do you start off so good and then the numbers aren't as impressive? So the pure definition of screening depends on the patient being asymptomatic. And that is, as opposed to a difference in technique or what have you, it's really the patient is the definition. But there's an exception to that, and that is screening the opposite breast in a newly diagnosed patient. That kind of blurs the line between screening and preoperative mapping. But I have a case history. In 2001, a 55-year-old female was sent to me for a second surgical opinion from another surgeon, newly diagnosed DCIS in one breast. She had a single question. I'm told my breast tissue is very dense on mammography. Is there any way you can be sure there's not something on the opposite side? And I said, yes, breast MRI is under development. The leading expert is Dr. Harms, just across the state border in Arkansas. I can make arrangements for you to be seen there. So what happened in Arkansas? Dr. Harms found an invasive carcinoma on the opposite side. Without MRI, the patient would have had surgery for the non-life-threatening entity, leaving the life-threatening entity behind. Now, this patient played a major role in our facility because Dr. Stal Clinton and I were building up MRI and getting people ready. And we had a lot of people that didn't really think it was necessary, but this single patient changed everybody's mind. So it really was an unusual sequence. Well, 11 years later in 2012, Dr. Stal and I published what was then the largest series of breast MRI when applied to newly diagnosed DCIS, just like in this patient. And we had one question, not other areas of DCIS, but we wanted to know how often does this occur when there is unknown invasion elsewhere separate from the lumpectomy site or from the tumor site. And it was about 2% on each side. And this patient that we had seen, the chances of her having a cancer on that opposite side were only 2%, but the implications and the importance of it are really extraordinary. It's a matter of life and death in this one patient. So like I said, the opposite breast can be considered as screening when that breast is asymptomatic, slight variation of the definition, and there's no right or wrong. You just have to, when you're looking at a study on screening, you just have to say if they included cancer patients or not. But that wasn't the most dramatic example. We had an even greater example of the same phenomena after we had established our program in Oklahoma City with a 75-year-old with DCIS on the right, diagnosed at a facility with an active breast MRI program. She was told she did not need MRI, however, because she had a low density pattern. This is the selective approach for pre-op MRI. That is maybe the most common practice in the United States today. We, however, did MRI routinely for reasons that we could justify and that you really don't know when you need it or not. But at any rate, this patient had 3 quadrants that were level A density. They just fatty replacement, but just had an island of breast density in there. And the twist on this story is that she was told it would be fine for her to take her 3-month vacation around the world that she'd saved for years because she did not have a life-threatening form of cancer. So on the opposite side, we have 2007, 2008, and she decided to stay with us at our facility where we did MRI routinely. And here was the right side with her DCIS, but on the left side, she had a 2.5 centimeter invasive ductal carcinoma, grade 3. And despite the claim, now imagine she's going on a 3-month vacation with this in her left breast. Despite claims that MRI discoveries on the opposite side will be an earlier stage than the known stage, our pre-op MRI series overall, both invasive and DCIS, showed that the unknown cancer was the same stage or even worse in over half the discoveries. So returning to the pure definition of screening, that is a public health policy established to detect undiagnosed disease in an asymptomatic population. Early detection is the key. We know that, we believe it. However, it may not be as true as we think. It's actually unproven for many types of cancer, and not everyone agrees it's true even for breast cancer. Now, it's a minority, but there still are epidemiologists who do not believe that mammography is making a difference. In the United States, survey respondents from the general population have a vastly overblown impression of the impact of screening mammography. And guidelines today are backing off of screening, failing to distinguish that early detection and mammographic detection are not exactly the same thing. In fact, mammography may be merely scratching the surface of early detection potential. So when you're screening for any disease, you have to ask, is it effective and is it practical? Those are 2 separate things, but you need both of them. And the question at the bottom is rather unique. Will improvements in treatment render screening unnecessary? If you have a treatment that is 100% effective, you really don't need to screen for a disease. But what's happening in breast cancer today, as part of the backing off on screening, we are hearing oncologists say we have such good precision medicine with our chemotherapy and biologic weapons that it's making such a difference that we can back off on screening now. And I won't belabor that, but I can tell you the numbers do not really support that statement. So effective screening depends on only 2 variables, biology and sensitivity of the screening tool. It's remarkably simple in first glance. just two variables. So X times Y equals Z, Z being mortality reduction is the gold standard for a screening program. However, we will see that surrogates are finally being accepted to get quicker answers. So all these other parameters, like how common is the disease, specificity, cost, access, that pertains to practicality and has no impact on mortality reduction. So when I say biology, I'm talking about a vulnerable biology where there's a window in which the early detection can halt the progress of disease. Another term is sojourn time, is essentially the same thing. It's converting biology to a time frame. But so you'll see sojourn time used as well in this discussion. Well, does the biology of breast cancer even lend itself to early detection? Oddly enough, the Fisher theory of how breast cancer works and overarching biology was one of biologic predestination, and it would have said no impact of mammography. And this is a theory that says tumors are either local or systemic. They don't progress from one to the other during the clinical window. This allowed breast conservation. This theory was generated, and it's the backbone of breast conservation. However, at the same time, Fisher was proving his theory through prospective randomized surgical trials. The screening mammography trials were underway at the same time. They were based on Halstedian theory of how breast cancer works, predictably from breast to lymph nodes, finally to the rest of the body. And oddly enough, both sets of clinical trials, even though the theories were diametrically opposed, both were successful. So while widespread mammographic screening facilitated acceptance of breast conservation, the true foundation of lumpectomy rests in a theory that would have predicted very little benefit of early detection. So you can see it's really not just this real straightforward early detection saves lives. So the prospective trials that were going on at the same time as the surgical trials, this is the entire list. And so when you look at those, you are immediately struck by how old they are. And that's because in the modern era, no one would do a trial that would randomize somebody to no mammography. It would be unethical. So we're stuck with these old trials. And this is part of the problem in trying to prove the benefit of mammography. But people are surprised that only the Swedish 2 county reached statistical significance for mortality reduction on its own by itself. The others may have trended toward benefit, or like the Canadian trial had no benefit, but it took meta-analyses to prove that mammography saves lives. So what did the 8 meta-analyses show? And I like to joke they showed anything you wanted them to show. Everybody brought their bias to the table, and the anti-screeners calculated 0 benefit. But I like to point out that the U.S. Preventive Services Task Force is tough on breast imaging and mammography, but yet they still calculated reductions in mortality through their meta-analysis that they performed. And there was an 8% mortality reduction, women in their 40s, but that was not enough to recommend mammography in their latest recommendations. So it really turns out to be the official numbers are kind of modest. They don't strike you as just a great benefit. It's a modest mortality reduction of 20 to 30%. The Swiss Medical Board in 2014 said that's not good enough. So we thought 8% wasn't good enough. They say 20 to 30% is not good enough. And they started phasing out mammographic screening. Well, what does this 30% mortality reduction mean? There's different ways to explain it, but one way, we all hear about 1 in 8 women developing breast cancer during their lifetime, or 13%. However, if you don't do any screening, there's only a 3% chance of actually dying of breast cancer. So a 30% reduction would be from 3% to 2%. Are we really screening the entire US population to get 1%? Well, yes. And if you translate that 1% into actual numbers of patients, it's huge. So you have tens of thousands every year, hundreds of thousands over a short period of time where lives are saved. So the general trend has been to cut back on screening, but this approach is based on the false premise of good sensitivity of mammography. and the numbers quoted will be in this range 70 to 90%, leaving the only variable of our equation as an overarching biology that does not lend itself well to early detection. They say X is the problem, can't do anything about it, that biology. The alternative view, which happens to be my view, is that we don't have good sensitivity. We have poor sensitivity with mammography, ranging from 40 to 70%, with the low end being for women with dense breast tissue. When you look at long-term incident screens, and I'll explain that more in a minute, but this is the problem, not the biology, which in fact does lend itself to early detection. So me and many people like me say, Y is the problem, not X. So today we have these conflicting recommendations for mammographic screening that we live with, that we used to argue about all the time. I think COVID distracted everybody, but it was at meetings and everywhere else, people were arguing about what the guidelines ought to be. And so today we just live with this range from the task force, biennial 50 to 74, and then the other end of the spectrum is Society of Breast Imaging, starting at 40, yearly starting at age 40. Well, the road to those conflicting recommendations has not been pleasant. And the 40 to 50 debate has gone on since the 60s, as has the annual versus biennial. But the debates escalated in the 1990s when the controversial Canadian trial announced that women in their 40s have an increased chance of dying of breast cancer if they undergo screening with mammography. And this was not presented at a meeting or publication. It was presented in the London Times, where somebody had leaked the information, interviewed the scientists who were then quoted in the article as saying things like, "We suspect that mammograms are compressing the breast and squeezing tumor cells into the bloodstream." Let me tell you what that did to a practice devoted entirely to breast screening and breast cancer. It almost paralyzed us for a long time. The National Cancer Institute jumped in and said no screening for women in their 40s as a result of this. Then they looked at the data a little closer and how many things were wrong with that information. And they flipped back to, yes, go ahead, in 1997. The media coverage was relentless. It was like COVID-19 today. The patients were distraught. Back in 1993, a small group of us started risk assessment programs in the United States. And this meant discussing imaging and future imaging with every patient. And it was paralyzing. Every single patient thought we were trying to kill them with mammography. And it spawned this book, The Breast Cancer Wars. So when things finally got peaceful, I said, why not write a book on peace rather than war? And what happened was in 2002, we had peace at last. After a decade of fighting, the task force endorsed annual screening starting at age 40. And for the first time in the history of mammography, everybody was on the same page. And I knew that when the MRI screening guidelines came out, I said, what we need now is to introduce this new modality to the public. And I began writing a book for lay and professional audiences on MRI screening, sort of in a creative fashion, make it fun to read. Well, in 2009, the task force reversed their position, as they used to do every time they met, and they went back to age 50 biennial. So everything I'd written was out the window. I had to start over now on a new book, having to justify screening with mammography before making the case to move on to MRI. So that ended up with the publisher asking me for 10 titles. All of them contained MRI. All 10 titles were rejected, and they gave me this rather boring title, but still, this lecture is an attempt at a 60-minute version of this book. Now, in that book, one of the things I go into great detail on are the 4 biases that inflate mortality reduction. And in an observational study for the epidemiologist, it's not a matter of if, but to what degree these things are happening. And there are expert epidemiologists who even today believe the entire benefit of mammographic screening is due to these biases. But for the majority, these biases are corrected through prospective randomized trials. To try to explain lead time bias just briefly, lead time is when you have 2 patients, patient A, patient B, they both get their first cancer cell on the same day, and they end up dying 10 years later, let's say, on the same day. So their biologies are identical, their outcomes are identical. Patient A does not get screened, but she feels a lump and has this duration of survival. Patient B has a mammogram, has an early diagnosis, everyone's excited, but she ends up dying anyway. But if you measure things in terms of survival, you come up with the conclusion, women that have mammography have longer survival, but they don't. It's an illusion. And this is what we mean by the biases. Now, length time and overdiagnosis, I don't have time to go into. They're variations of the same thing, but they're generated by screening at regular intervals, wherein the most aggressive tumors emerge in between screens. So the screening tool is prone to identify less aggressive, slower growing tumors. And the extreme version of that is overdiagnosis. It also became extremely controversial about 10 years ago and caused a storm of debate at meetings. And to what degree do we have overdiagnosed cancers? That is, cancers that actually would never kill the patient. And there's a huge range calculated indirectly. And I wrote this editorial and a summary of the problem just because my personal belief was that we were at the lower end of that spectrum. But again, people were being scared away from mammography due to this overdiagnosis issue. Well, this is kind of a busy slide, but I wanted to point out that there are other sides of the coin. Are there features of randomized controlled trials that really result in underestimation of the benefit of mammography? And yes, there's quite a few, as a matter of fact. One is primitive mammography, obsolete techniques. We would find every mammogram performed unacceptable by today's standards. Single view studies, no CC view misses 10 to 20% of cancers, long screening intervals. But the one that really gets people when they start to think about it is the intent to screen rule for randomized controlled trials, the same as the intent to treat rule for pharmaceutical studies. And that is, there are major compliance contamination issues that prompt two sets of data when a trial is done. There's the official results based on assigned group independent of what the patients actually did. And then there's unofficial results based on actual compliance. Unfortunately, number one is what all the guidelines are based upon. Well, compliance is the percent of women that are assigned to, say, the mammography group, but they don't get their mammograms. They are still counted in the mammography group as if they'd had mammograms. The opposite, you're assigned to no mammograms, but you have them done anyway. You stay in the no mammography group. Now, if that seems absolutely nonsensical to you, it does to all clinicians as well. This is a golden rule by the epidemiologist, and they will not budge on it. It's a critical feature of a good prospective randomized controlled trial. So everybody kind of sneaks in their compliance results into the articles to go along with the official results. But these are not small numbers. A typical example would be this study had 25% non-compliance, 18% contamination. So these official results are diluted. The true benefit of screening is diluted by both compliance and contamination. Yet this is what goes into the meta-analysis. This is what makes our guidelines. The actual benefit is, like I mentioned, it's in the publication. Sometimes it's even in the abstract. You can tell the researchers want people to know what the true benefit is. So in an observational study that gets maligned, it's important to point out, by definition, compliance is 100%, contamination is 0. Yet we reintroduce the big four biases. But a good observational study would be the Pan-Canadian study, close to 3 million participants, showed a 40% mortality reduction, including women in their 40s. And this happens to be similar to when you read a prospective randomized trial and look at the compliance data. It will be very similar to this 40% reduction. So back to our formula, we cannot control X. The only measure we have against X is to change the interval between studies from 1 year to 2 years or 6 months. After that, everything rests on Y. It all boils down to screening sensitivity of the screening tool. So in our formula, if X is constant, the biology, and mammographic sensitivity is truly 90%, then there is very little room for improvement. We have this 30% mortality reduction, and we're pretty well stuck with it. But this is the slide that really sums up why I've done what I've done in the past 30 years, leaving surgery and moving into high-risk screening. is that if it turns out that mammographic sensitivity is only 45%, half of what we've been taught, rather than 90, and X is constant, then one can theorize that the mortality reduction will double from 30% to 60% if a truly 90% sensitive tool is used. Critics of that theory, and there are many, would say MRI might not lower mortality much further than mammography because there's evidence that you just need to find cancers 1.5 cm or less, and that's the mean size for mammography. How much improvement can really be imparted by lowering this a few millimeters? Well, my response is the primary purpose of MRI screening is not to find cancers earlier than mammography in terms of mean diameter, though I think this is probably part of the effect. But the primary purpose is to find those cancers that are large enough to be seen on mammography, but are missed on mammography, perhaps year after year, due to surrounding tissue that's dense and allows the tumor to remain occult until stage advances and the chance for a cure is lost. And I'll draw your attention back to this year after year. We're not talking about mammograms that miss a cancer one time and it's picked up the next year. We're talking about things like invasive lobular that are there for many years with mammograms being normal. So it's not just a single year phenomena. And these are just tragic stories that occur because of that phenomenon. So we're going to redefine the true sensitivity of screening mammography. It's a myth that mammography detects 90% of cancers in asymptomatic women, even though Time magazine said that on October 15, 2007. They were actually doing an article, a feature article on the new screening guidelines for MRI from the American Cancer Society. And in that article, they point out that mammographic sensitivity was 40% in head-to-head versus MRI. So on the same page of the magazine, to show how split-minded we can get, they had 40% in one location, move over to the sidebar, and they had 90%. So old myths die hard. And I'm going to skip this for the sake of time. Similar phenomena with publications by the American Cancer Society. So historically, 90% gave nearly everyone false confidence, but it ended in malpractice, crisis, reluctance to accept other imaging methods, and curtailing research. Within a few years of its introduction, mammography and failure to diagnose breast cancer became the #1 cause of malpractice in the United States. And the most common sequence was Kern's triad of error. Young patient discovers a mass and had negative mammograms. In years past, she would have had a biopsy, but because of the negative mammograms, they would be told you don't need a biopsy. And this was due to the 90% belief. What is the true sensitivity of mammography? And here's our formula for sensitivity, and the key there, how do we know our false negatives? But stated alternatively, it's really the percentage of cancers detected by a screening tool. And when first introduced in the 1970s, there was no other imaging modality reliable enough to determine the false negative rate. So how do we calculate it? How do we know a cancer was missed? And we'll come to that in a minute. Well, on a personal note, after switching to breast cancer surgery in '89, my experience told me something was wrong. Many patients whom I biopsied, and they were all surgical biopsies back then, had palpable breast cancer and negative mammograms. So my first academic paper was in 1993, and I had an interest in breast pathology. So I just said, I wonder what these look like under the microscope, the ones that don't show up on mammography. And at that point in time, even though we didn't have the internet for a search, but through Index Medicus, we searched and found only 3 papers that had been written on the subject of false negative mammograms. And they had identified both density and invasive lobular in those 3 papers, which today remain the biggest concerns. But for background on this article, I began searching for the 90% sensitivity. Where did it come from? I couldn't find it, nor could I find anybody that could tell me where it came from. But in our paper, we found it wasn't just invasive lobular. There were 2 patients that had a very rare histology, and this was multifocal deposits of medullary carcinoma. No deposit more than 5 millimeters. These are 2 different patients, and yet their tumors looked alike. Both were mammographically invisible. So we ended up using the term diffuse histology rather than lobular. 5 years later, this paper was selected as one of the top papers in oncology in the journal's 50-year history. I never was able to recreate or reproduce that much attention to an article for the rest of my career. But at any rate, beginner's luck. The conclusions, and this is 7 years prior to digital, 10 years prior to MRI, diffuse histology is a bigger problem than invasive lobular. We've got invasive ductal and DCIS that can have diffuse histology and skip detection, and therefore it's likely to be, or more likely to be invisible on mammography. And then I went out on a limb. Mammography cannot be perfected. Digital will not be the answer. Improvements will come through technologies that have a physiologic component, such as MRI. Now, I was influenced at this point because by the time I was writing this, I had heard Dr. Stephen Harms talk and present his data, so I kind of knew what was around the corner. Nevertheless, you could say I became rather obsessed with this 90% and what the true sensitivity was. And every time from that point on, from every time I would read an article about sensitivity, if it claimed to be even over 80%, I would read the article, figure out how they arrived at their number, and found out that there has never been a true 90% in asymptomatic screenings study. So I did this for many, many years. So I had all the origins of these numbers memorized. And in 26 years later, I went back to the same journal and published a comprehensive review of how do we get our numbers that we use for sensitivity of screening mammography. And that was my magnum opus from a few years ago. So what is the number? Well, it's disingenuous to talk about a single number because the sensitivity of mammography is highly dependent on the density. And so it doesn't make good sense to come up with one number like we did before. And this has become gradually apparent. It took a long time, seems like 15, 20 years to break the 90% ice. Now, when you hear a radiologist start out their talk, they will say things like, we know mammograms are 80% sensitive, though 50% or less in dense tissue. And that's pretty true. That's a true statement, except it sounds to me like dense tissue is an outlier, but there's just a few women out there that it fails on. But 50% of women have dense tissue. So if we're going to do a single number, we've got to add 80 and 50 together, and we get 65%, which actually turns out to be pretty accurate if you're going to use one number. Well, how does density interfere with mammographic detection? Here's a 1 centimeter invasive ductal, easily detected on mammography because every interface is fat. You may not be able to see that this is adjacent to adipose tissue all the way around it, easy to identify on mammography. But this cancer, same size, is invisible on mammography. The invasive ductal and normal tissue, and this is not diffuse histology. This is a very well-defined pushing border that blends perfectly with normal density, and they have the same density over here as here. So this is encased in density that is white, and it's the same white as is the cancer. My point is, overall density is not the story. It's kind of a surrogate. The real issue is what's immediately adjacent to the tumor, the normal tissue versus tumor interface. This takes on much more significance if it turns out the cancer is more likely to arise within the white patches. And there's some evidence for that, allowing cancers to be missed even when the overall density is low. So today we have a powerful grassroots movement for density, both as a risk factor and a predictor of missed cancers. There are some caveats. This awareness has turned the continuum into a dichotomy. Dense versus non-dense can be misleading to patients and physicians, especially when it's subjective, and there are some objective tools out there, but no one is average under this approach. You're either B or C, and there are ramifications. But the truth is it's a bell curve split down the middle, and most women are clustered on this B-C borderline. And so it is a little bit frustrating there. And of course, we use 4 levels, A through D, as a better option than just a dichotomy. But then you have to translate that to recommendations and what will insurance cover and all that. So it's a problem that needs to be worked out. There are qualitative aspects I'll show. There are strong ethnic differences. Asian women have a greater breast density. The paradox is they have a lower incidence than in the United States of breast cancer, but a greater false negative rate with screening mammography. And then there's the imparted risk from density is often overstated. That's because they're using level D compared to level A, and it's a relative risk. And this chart kind of shows that relative risk increasing density with, these are relative risk numbers. A relative risk is always a fraction, numerator and denominator. So what's the denominator for these numbers? It's a 1, it's having no density at all, which is kind of a rarity. And so this is how you get level D. This isn't A through D, but still, this is how you get the extreme density. Compared to this is 5-fold in relative terms. But if you compare this patient to the average, somewhere in the middle, it's about a 2-fold risk for breast cancer. Fortunately, our mathematical models today calculate, and they don't show us the relative calculations. They just give us an objective number. Qualitative aspects to breast density. This is an unusual pattern where it looks like there's a cancer everywhere, but it's a mixture. I think most would call it level C, but nonetheless, it's an unusual pattern that our computerized assistants would place 10, 15, 20 arrows telling the radiologist to work them all up. But in our case, Dr. Stow was able to, with her eagle eye, able to just spot that cancer. And then the MRI proved that all the rest of this stuff was nothing, all of these little patterns. So the qualitative aspect is not really addressed. Now, MRI on this patient, breast density was level B. So this is a 1 centimeter invasive ductal, grade 2, node negative, and the white area is the tumor. That's the contrast. And she was older. Her lifetime risk was low, but short-term risk was high. She did not qualify for MR screening by cancer guidelines. We'll go over that in a minute. But the white is the contrast. The light gray is the parenchyma, the normal breast parenchyma. Dark gray or black is fat. And you note that this tumor is about to interface, already is interfacing with fat just barely in 2 locations. And if you saw this 3-dimensionally, this is about to become evident maybe within a month or 2 on mammography, but she would have had a clear mammogram and they would have said, see you in 2 years. And this shows you how important the interval is. When the task force says we're going to screen cancer for cancer every 2 years, they get okay with that because number one, they would not have approved the MRI in the first place. And now that we know this is there, their recommendation for this patient is to wait 2 years for your next screen or until the tumor becomes palpable. If you encounter a publication that claims 90%, then one of the following is going to be true. It'll have patients with palpable masses. It'll be a subgroup. It'll be based on prevalence screens or the inverse of interval cancer rates. Those are kind of complex terms, but we'll go over them here for a little bit better understanding if you're not familiar with them. So if in a publication, a range is provided, if that top end goes over 95%, same thing. It's just not true. It's not right. Well, the origin of this myth turned out was this huge demonstration project for mammography in the 70s when we should have been doing prospective randomized trials. We had the war on cancer going and they did 280,000 women. It was a feasibility study. Just can we mass screen the population? And a lot of these tumors were palpable. There were more stage 2 cancers than stage 0 and 1 combined. This was not a screening trial. It should not be the origin of our sensitivities. And yet, for the 30 years that followed, breast centers would include this disclaimer on their reports: 5 to 10% of cancers are not detected with mammography. And it would have been almost true, or true if you'd have put the word palpable in there, but that's not screening. 5 to 10% of palpable cancers not detected. So what did the historic screening trials show, which is a better source, except that the mammography is obsolete now, but nevertheless, in this study, yes, you have subgroups. Go over here. If you're between age 70 and 74, there's 92% sensitivity in this study. The yellow, by the way, on this slide is for all screening rounds, and it's a sensitivity determination. And then the pink salmon color is for just the prevalent screen. And so we end up here. Let's just take one of the studies. In this study, the prevalent screen is 30 percentage points higher than the incident screen. There is a huge difference, and yet we'll show how these numbers can be manipulated. Large tumors equal greater sensitivity. Palpable tumors are larger. That's why you have 90% sensitivity. Prevalence tumors are larger, the first screen only, and this too translates to higher sensitivities. So how does that happen? If we've got prevalence screen, just the first screen, these are tumors that built up in the patient for 2, 3, or 4 years. There's more of them, yield higher, and they're larger tumor size on this parameter. So if you have a fixed threshold for detection, we'll say 1 centimeter, reliably going to find cancer at 1 centimeter, that first screen, you get an 80% sensitivity. But now we're starting over with the second screen through the rest of the patient's life. It's now 50% sensitivity. So that's how the prevalence incidence phenomena works. So we're going to measure mammographic sensitivity. And in the beginning, all we had were 12-month follow-ups. This became a standard. But people pointed out that any cancer arising within 12 months, not only was it called an interval cancer, but at first it was calling it a mammographic miss. So they would say 20% interval cancer rate means that mammograms are 80% sensitive and you can't do anything about it. And then it became evident that that wasn't really accurate because these are aggressive tumors, was the belief. And these probably, if the mammogram was negative ahead of time, maybe it wasn't even there. So it's really not a false negative, it was a true negative. And what happened were these are just really aggressive tumors that pop up after the mammogram's done. Well, it's finally been sorted out. Breast MRI has shown something else. Most of these are routine biology, and they are present on the prior mammogram, simply not seen or diagnosed. As a result, reduction in the number of interval cancers is now recognized by some as a surrogate for mortality reduction. This study helps show that what's really there a year earlier. This is a group of expert radiologists who took 493 newly diagnosed patients that had cancer on mammograms only. So these patients were thrilled. They had an early diagnosis on mammography. Then they went back and looked at the mammograms 1 year prior, and 58% of the time there was something there that could have made the diagnosis of cancer. And this is probably, an MRI would have found probably all of these and maybe some more up here. Shows you what's happening 1 year earlier. And so it turns out that the interval cancers are really not coming out of nowhere. They were there. So these approaches to false negatives, we have the 12-month follow-up. A better way is multimodality imaging. And then of historical interest, in the early days of mammography, we had mastectomy specimens were a measure, but that's not anymore. So a major trial was DMIST, and this was comparing digital mammography to the older film screen technique. Can we shift from one to the other? It didn't even have to, digital didn't even have to be better for a successful trial. But they used 12-month follow-up. They also, realizing the arbitrary nature of 12 months, decided to calculate 15-month follow-up with some surprising results. We start off here with digital versus film screen, slight advantage of digital. Remember how we came up with 65% earlier just by averaging two numbers together. This is general population screening, not high risk, not high density. But look what 3 months of additional follow-up did. If you count any cancer occurring within 15 months as having been there before, you've got 41%. And this number will match up perfectly with the MRI comparison studies that will reveal mammographic sensitivity at 40%. Another busy slide, but I just want to direct your attention to this group because it's the one that got all the headlines because it was strongly statistical significant. And this is 50 and under with dense mammograms. Film screen, 27% sensitivity. Digital, there was a huge improvement, but 59% is still substandard. And no one mentioned this. They just said how much better digital mammograms were in dense tissue. But of the 20 sensitivity determinations in this paper, only 3 were even above 80. None reached 90. So for level D mammograms for 20 years in film screen technology until 2000, these patients were told they had 90% sensitivity when in fact the number was 27%. Or even lower, since the 27% was both C and D patients. Why did this myth persist for so long? And I'm not sure, but I say both sides of this battle needed to believe in 90%. The American Cancer Society and others had to confirm what they'd been promoting since the 70s. The task force, it's a little more subtle. Maybe it's conjecture, but if sensitivity is only 40% in women with dense tissue, the blame has to be shifted away from biology, which has been my premise in the beginning, and that it can't be changed. The biology that can't be changed to improving sensitivity. So the emphasis then is on improving sensitivity. That is doing more, not less. And the task force is not inclined to move that direction until they have convincing mortality numbers. What about 3D? Well, there is improvement. In fact, this is the greatest technological improvement in mammography since it was introduced. We can measure improved CDRs. There is a range, but the detection is mostly invasive cancers, over 90%. Fewer callbacks, biopsies. This ought to be ideal. You'll see in a minute. The task force wasn't good enough for the task force. But still, patients then said, can I get out of my ultrasound this year? Can I skip at my MRI now that we have 3D? Unfortunately, it may be a surprise, but 2D digital plus ultrasound is much more sensitive than 3D alone. That's surprising to people, and there'll be more data coming on that now. The most mature data is the ASTOUND trial in Italy. MRI, far more sensitive to 3D, 97% sensitivity versus 39 in a recent study of MRI experts. And this TMISS trial is now randomizing to one or the other, either 2D or 3D, with reduction of advanced cancers, the endpoint, primary endpoint, a surrogate, again, for mortality reduction, may not be acceptable to the task force, which wants to see a mortality reduction. Results are pending. So the best way is simultaneous imaging. Numerous ultrasound studies, but they're mostly in high density populations. MRI has been restricted to high risk populations. So ultrasound has a strong pro feature. It can detect those cancers embedded in dense tissue, usually invasive, usually node negative. The downside is specificity, low positive predictive value, often in the single digits. So you have excess biopsies, although that improves with experience. Now, MRI screening, I show you this complicated table of sojourn, lead time, screening, only to explain why I simplify it. And for 20 years, I've used my iceberg slide. And this says the same thing, only it's much more easy to understand. We have at the water level, above that, we have the tumor biology that, if found early, lends itself to a reduced mortality. Early detection works at this level. Yes, we have 90% up here, but these are palpable cancers. Here we have undetectable cancers. We're not sure what they mean, but they're eventually going to work their way up. But this is the key group, and we're seeing a mortality reduction, even though we're missing up to a half of them. Certainly more than a third are being missed. So if we now add MRI, what happens? Two things. We have the MRI now finds virtually all the cancers at this level missed by mammography. Now, the attention and everybody's focused on our earlier diagnosis, smaller tumors. That's got to be good. This is the group that may or may not make a big difference, because we don't know if finding cancers at 8 millimeters is better than 1.2. But up here is the reason for MRI screening, primary reason, and this may be secondary or not at all. So here's a typical study and addressing earlier detection as opposed to more reliable detection. Here's mean tumor sizes. Yes, it's smaller, 5 millimeters, not too impressive, but I always draw attention to diameter as a surrogate for volume. And there's the formula for volume. And if you convert these tumors, it turns out that this tumor is 4 times the volume of this tumor. So this could have a role. It's very difficult to prove one way or the other. So a combined analysis of 5 of the 7 MRI trials said it all, with one caveat, and that is mammographic sensitivity, 40%, a number that keeps showing up. You add ultrasound, it doesn't make much difference. It helps a little bit, but if you have, when you have MRI, now if you don't have MRI, the ultrasound benefit is more evident. but when you throw MRI in, it almost makes ultrasound not needed. And here the number is low because these trials are 20 and 30 years ago using dynamic techniques that are not in use today. So it's a little bit deceiving there. And Aurora decided to get some modern data for people to look at. And we had 4 sites participate in this study. Overall sensitivity, 92%. Overall specificity, 89%. So again, this specificity number, much better than what is often quoted by dragging out studies that are 20 and 30 years old. Now, I want to give an example of how it's important to know these numbers to see when you're being manipulated. This is the 2009 task force, and mammography was described as having a sensitivity of 77 to 95%. I look up the reference. It's their own meta-analysis. It's their own prevalence data exclusively. In that same paper, they calculated the incidence, the sensitivity in the incident screens, and they reported 39% to 66%. This is the real long-term sensitivity. The prevalence data is highly misleading, but this is the long-term for the rest of the patient's life. That's the sensitivity they're looking at. Task force own data, yet not included later when they start talking about guidelines. Now we move to MRI sensitivity. They've got the same range. That's because they went and found these old trials from dynamic MRI low sensitivity, and they've created identical ranges here. But these include all screens, not prevalent screens. And so this is a very bothersome situation when you see 2 modalities presented as roughly equal, and yet at the same time, MRI is going to find 3 times the number of cancers as this modality. So what did the MRI screening do to the interval cancers? And the acceptable number in the old days was 20 to 25%. We just had to learn to live with it. For high-risk women, though, the number is higher, about 40%, and it can hit one study 60% interval cancers. Well, in the prospective trials for high-risk patients, the range of interval cancer is from 0 to 9.8. This is really overlooked and unbelievable effectiveness, is because now what they're doing, they're catching those cancers I showed you earlier that were detectable 1 year earlier. One outlier, BRCA1 positive, and this is just one study, had a high interval rate, 32%. The BRCA1 positive patients in other trials did not, so we're not sure exactly what that means at this point. Now, very interesting trial is this from Akron, American College of Radiology Imaging Network, primarily to explore the impact of screening ultrasound in a cohort having both risk and density. Now, they had their own density levels and risk, but the important thing is risk and density carried equal weight. All participants were offered a single MRI at the end of the study, and that's after they went both ultrasound and mammography. Every patient had both at 0, 12, and 24 months. Sensitivity is before we get to MRI. Just the sensitivity of mammography was the same as ultrasound at 52%. Both of them together, still only 76%, and we haven't added MRI yet. But this shows the care and the well thought out strategy in this trial is they didn't show us prevalence numbers. They actually excluded the prevalent screens and showed us the long-term, the true screening sensitivity for the second and third screens. But now we add MRI and we lower the combination of mammogram and ultrasound, 44% sensitivity. This is the same number we had back in the combined analysis of 5 of the 7 MRI trials. The numbers in this are just remarkably the same across study after study. So you can plot things like the incremental cancer yields, or CDRs. And this is different. You'll see different numbers and different modalities doing this exercise. We start with 2D mammograms at 5 cancers per 1,000 screens. 3D adds some more. Ultrasound adds more than 3D even. MRI adds more in the general population, up to 15. But high risk screening, now we get up to as many as 30 per 1,000 or 3% yield. And this brought up all this attention on dense breast sensitivities new ways of imaging, the task force, U.S. Preventive Services Task Force, decided to render an opinion on this grassroots movement on mammographic density. And they decided evidence is insufficient for anything you can think of, including MRI, ultrasound, digital, 3D, or other methods, that's their term, that might be available in women with dense breast tissue. So here's sensitivities with dense breast imaging options, up to almost 95% with MRI. And we start off with 2D. We add 3D, ultrasound, we just keep improving over time. But this rendering of opinion by the task force, because of the lack of mortality data, gives us this option. All the things that make life better and make detection better is put on hold. And the recommendation for women with dense breast tissue with terrible sensitivity is to use the worst possible tool available for cancer detection in women with high dense tissue. Well, backing up in time, in 2007, the American Cancer Society gave us our screening guidelines for MRI. It was annual MRI, annual mammography, beginning at age 30. The fact that the age was dropped was kind of lost in the shuffle because all the focus was on MRI. This was based on the entry requirements of 6 available screening trials, and the panel felt obligated to follow the entry criteria as close as possible, given that these new guidelines were based on sensitivity levels without proven mortality reduction. So they went out on a limb, and the media covered all these kind of rare instances, but what the impact of this was, this also launched the world of risk assessment to the general practitioner, breast practitioner. And this was getting a lifetime risk of 20 to 25% or greater based on mathematical models. And so those of us that had been doing risk assessment for 14 years at this point, suddenly it wasn't a matter of studying the nuances between models and so forth. It was trying to get the highest number to get insurance coverage for the MRI. And that's been kind of a sad side effect of all this because these models are very good in predicting number of patients in clinical trials that will get cancer, but at the individual level, their accuracy is not that great. So it's kind of especially in disarray now. So the jury is out, said the American Cancer Society, for these entities, and note that dense mammograms are thought of conceptually more as a risk factor, 15 to 19%. MRI screening specifically not recommended if your incidence is less than 15%. If your risk, lifetime risk, less than 15%. The problem with all this is that by using lifetime risk, we forget that that is remaining lifetime risk, a number that drops over time. And so while patients age, it gets harder and harder. They need more risk factors to justify MRI, which shouldn't be the case at all because their short-term incidence is rising. And this conflict, I don't have time to give you examples, but it's kind of surprising some of the consequences for older patients using lifetime risk. So we, in cancer epidemiology, we recently published, this is sponsored by Aurora, allowed us to do this study, in lifetime risk are age discriminatory when used for high-risk screening with MRI. The frustrating thing is, I've been talking about this since 2007, is that it is so easily fixed. You go back, what did Akron trial do? They used short-term risk and long-term risk. And the same thing could be done here. If you add the short-term risk calculation to go with the lifetime risk, you have all your bases covered, yet there is no headway in that battle yet. So in the 2007 Cancer Society guidelines for MRI, breast density is treated like a risk factor. However, I think that the camouflage effect is far more important than the risk, modest risk elevation. And so in considering two modalities, it seems to me the number one question would be, what's the probability that mammograms are going to fail? That probability ought to adjust our recommendations. So I think the Akron people were right on. I think the fact that we should use both density and risk. Well, as a matter of fact, that's what we came up with in 2003, prior to any guidelines. We were on our own, and I didn't realize the importance of this at the time. I just did this for an in-house strategy. We're going to make risk level and mammographic density equal in its power. And we've got, this isn't just a random, there's a way to figure out whether patients are 1, 2, or 3, drawn from a working group of risk assessment sponsored by the Komen Foundation long before MRI recommendations came out. Anyway, what's the upshot of it? Not just whether to get an MRI or not, but what should your interval be? Do yearly, every 2 years, and every 3 years. And this was based primarily on biology, sojourn times, the mammographic screening trials for longer screening intervals. But these every 2 and 3 years can have a huge impact on your cost effectiveness. Well, we published that. Unfortunately, we didn't feature it. We published it in this 2008 article that was a response to the new American Cancer Society guidelines. At that point, we had 7 cancers detected, none of which would have been identified by the new guidelines. Why? Because high density in 6 of 7. 6 years later, we were up to 33 cancers detected. And even by then, only half would have been detected had we followed the ACS guidelines. And why? Again, density was driving the discoveries. So finally, we had to adopt those guidelines for third-party payers. And when we did, density is out the window, and our numbers of MRI detected cancers through screening dropped by 50%. So why not forget risk and focus entirely on density? Well, they did that in the Netherlands. They're doing it now in the DENSE trial, and that is level D mammograms qualify for MRI. Primary endpoint is interval cancers. So very simple. It's a very simple concept. I wish they'd gone to 40, but they had their reasons. 50 to 75, the only other inclusion criteria is level D mammograms. So they've reported in the New England Journal of Medicine already, 2019, a big success at this early analysis. Cut the interval cancer rate in half. Statistically significant. Story should stop there. Everyone's excited. I look at that and I go, that's not very much. Yeah, it's cut in half, but that's not that dramatic. Well, recall the intent to treat rule of prospective randomized controlled trials. In fact, compliance was 59%. Only 59% accepted the invitation for MRI. So what about the other 41%? They're counted in the group of MRI as if they had had an MRI. So of the 20 interval cancers, reading the fine print in the article, of the 20 interval cancers in the MRI invitation group, only 4 were diagnosed in women who actually underwent an MRI. So what we have here is one of the most dramatic results in the history of breast screening, the toughest women to make a diagnosis on, the worst sensitivity, high interval cancer rates, and the interval cancers have almost been abolished through MRI. And instead, we're focused on, well, we cut the interval rate in half. So that's how these numbers can play such an important role. Patient selection for screening MRI, high risk maximizes yields for optimal cost effectiveness, but includes only 20% of women. High density is more inclusive, but the CDRs are lower. Both high density and high risk, I think, is the ideal way to approach it. But why not screen the general population with MRI? Well, there's cost, feasibility, infrastructure, all sorts of reasons not to do it. But that didn't stop Christian Kuhl in Germany, who specifically targeted women with lifetime risk for breast cancer under 15%. This is the group the American Cancer Society guidelines say don't do it. Negative exam, negative mammography, most with negative ultrasound. CDR 15 per 1,000. But the surprise number is the prevalent CDR, 22 per 1,000. This is the same number you got in the high risk screening trials with gene positive patients, multiple family members with breast cancer, and yet the prevalence cancer detection rate is the same. And yet we're telling these patients, your MRI is not indicated. No interval cancers. So we have some amazing stuff going on right now, and it seems just to kind of glide by, but MRI is truly revolutionizing our detection rates. So this brief mention of the St. Mary's Hospital project in Taiwan, where the breast MRI was used as the primary imaging modality, and we we were actually looking at false positives and specificity issues, but our CDR of interest was 11 per 1,000. So both Christian Kuhl and the Dense Breast Consortium have addressed a solution to the breast density and the problem, and that is the interval. In 2021, the Dense Breast Consortium said 4-year interval is very cost effective. Maybe 3 years is cost effective as well. Christian Kuhl earlier, 2017, noticed the cancer, there seemed to be a shadow, a protective shadow of MRI that lasted for 3 years. But I point out again, sometimes the early bird does not catch the worm, but in 2008, implemented in 2003, we had 1, 2, or 3 year intervals. So recently, the European Society of Breast Imaging says in women 50 to 75 with level D, this is from the DENSE trial, you should offer MRI screening every 2 to 4 years. Is there an ideal way? Can we go beyond risk, beyond density, and be more precise than just extending the interval? Can you identify patients from the general population at risk for harboring breast cancer on a given day? In other words, they come in, they get their mammogram. Is there a second step you can do that tells you you ought to do on the MRI on that patient, regardless of risk or density? Well, I've been exposed to 3 approaches, actively involved in number 1 and number 3. And I'm going to briefly close with this research that we've done, and that is using artificial intelligence on normal mammograms to select patients for MRI. And this came from good evidence that this was going to work out of the Advanced Cancer Imaging Lab at University of Oklahoma. We got this R01 grant from the NCI, very unusual. I don't think it's ever happened that a private community hospital was able to land money for this level of research, a clinical trial, large clinical trial of patients that went through the system. My colleagues were Dr. Liu, Dr. Zhang at the OU, University of Oklahoma, Dr. Stow, Clinton, and Melanie Pierce helped us with the interpretations. Here they are at their lab in Norman, Oklahoma. What would happen, we'd send them the image, the digital image, they would come back using 5 image analysis parameters, convert to a risk score above 0.80, qualified for the patient for 1 MRI, but you can see what happened. The threshold meant everything. Here's 0.79. And what we ended up with, we probably should have adjusted our threshold midstream, but there was a challenge in doing that. But the threshold could have been adjusted, but we ended up with the same CDR as the general population. They're continuing that work. I am not in it now. COVID-19 kind of ended that. Using artificial intelligence to interpret non-contrast MRI. This is very exciting. This is using MRI without, more like a mammogram, and then use artificial intelligence to tell you whether or not to go ahead and use gadolinium. Dr. Wei, Chief Data Scientist for Aurora, is heading up this project. Very exciting. We hope to have clinical trials going soon. Conceivably, this could replace mammography. So I do have a picture, I believe. Yes, there's Dr. Wei. Hopefully we'll be hearing from him soon in a successful run that could really revolutionize breast screening. My interest has been for 30 years on a screening blood test. And this started in 1991 when I had a breast research consortium of scientists on campus that met weekly to cross-educate and help each other in different disciplines. And one day the senior scientist, Paul McKay, walked in with an article that he had found that had a screening blood test for breast cancer, work done in Israel. And I had just come back from Dallas, seeing Dr. Harm's presentation. Here's the normal, here's the cancer on MRI. And I put 2 and 2 together. I put the blood test and the MRI linked as a way to select patients. And now 30 years later, we are getting close. Traditional tumor markers aren't sensitive enough for early detection. Some of the new technologies get a lot of headlines. They're very specific, but in breast cancer, sensitivity so far is falling way short. So a good blood test has to have good specificity, but the sensitivity can actually be lower as long as you maintain a good level across all levels of breast density. This is patient one who had her blood sample tied to MRI result. That was the unique feature of our repository. I think it's the only one in the world where all the blood samples were linked to MRI. We had 2,000 volunteers and 10,000 aliquots of blood distributed around the world. And the blood test collaborators included three clinical trials, and we're in a fourth one now with Siantra. And they're having some excellent results. I've written on how you use a blood test because it's not straightforward. The performance characteristics have to be combined with multimodality performance characteristics and screening algorithms. It's not as straightforward as you would think, although this concept is very simple. If you have a 85% sensitivity and you move across the board of density, then at some point that crosses with mammography, and pretty soon you have a far more sensitive test than mammography. Of course, you still need to confirm and get a location. So you negative mammogram, but a positive blood test equals MRI. Siantra presented their work at San Antonio this past year. Overall sensitivity 80%, even better under age 50, and specificity 94%. As this holds up, this is ready to move into the clinic cautiously at first, but this is very close to becoming a reality, I think. So a negative mammogram, but a positive blood test equals MRI. But consider these applications as well for women who refuse mammography, for the controversial ages of 40 to 49, to fill in during screening intervals, and for women in countries with limited infrastructure for breast imaging. Here's the people that I'm working with in Canada, in Calgary, and the founders of the company, Bob Shepard and Christina Rinker. We've got multiple sites that are doing the studies and other sites that are starting to join a registry, and I think we might be on our way. So in summary, early detection with mammography saves lives, but impact is limited by poor sensitivity in dense breast. Imaging modalities with greater sensitivity than mammography should improve early detection in women with dense breasts and thus generate a greater mortality reduction than mammograms alone. Ultrasound screening improves cancer detection in dense breasts with a shift toward invasive disease, but at the cost of low specificity. Also lower sensitivity than MRI, much lower. Modern breast MRI performance characteristics reveal the highest sensitivity of all imaging methods, along with good specificity. Efforts should continue to use MRI increasingly as part of breast cancer screening options. So I'll close with this little vignette follow-up. In 2021, I was sitting in the reception area for my dental appointment. The receptionist said out loud, "Dr. Hollingsworth, we're ready for you." A lady standing nearby me said, "You are Dr. Hollingsworth. You probably don't remember me because I only saw you once. But 20 years ago, I was diagnosed with DCIS on one side. You sent me to Arkansas to get an MRI by Dr. Harms, and he found invasive cancer on the other side. It saved my life." I explained that even though it had been 20 years, I remembered her story quite well, as the impact of that discovery occurring in the years prior to routine MRI made believers out of many, and yet with a probability of only 2%. Thank you very much. And I want to acknowledge these individuals and the groups, the screening research team, and Olivia and Ashley, all those that contributed to putting this program together, and to my clinical staff back when I was in practice, seeing patients and running these research projects. They did a huge amount of work to make that happen amazingly in a community hospital. So I think we start with questions now. Thank you very much.
Dr. Hollingsworth is excellent.
Thank you very much, Alan, for this
Welcome.
truly comprehensive discussion of breast MRI, breast issues from mammography to MRI. Just let me make a quick announcement here. We are now starting this series of lectures. In fact, we even have the third lecture now set up. The third lecture will be given by Dr. Shi An Li, who is the chairman of the Beijing Love Book Cancer Foundation. I think she could say a few words here. Go ahead.
尊敬的冯校长，尊敬的 Olivia，各位嘉宾，大家晚上好。非常高兴能够参加我们今天从钼靶检测到核磁共振、乳腺癌筛查的升级这个直播节目。对于乳腺癌，在中国女性这是一个常见的肿瘤之一，并且现在已经宣布。统计学上就是说它已经超过了肺癌，成为女性癌症的第1位，所以这个问题呢是非常的严重了。据统计，发病年龄都高于了西方国家，发病高峰也提前了，是在45到55岁，而西方多在65岁之后。那么2020年新发病人已经超过了41.6万，由于没有早期发现，所以晚期患者5年生存率只有仅为20%，同时也承受着巨大的经济负担。最近我们国家发布了《健康中国2030规划纲要》和《健康中国行动计划》。在这个里面呢，明确的提出了，要实施癌症防治行动，要做到预防为主，早发现、早诊断、早治疗。而且呢，相应的出台了一系列的医改政策，而且呢，有一个明确的目标，就是到2030年，生存率在原有的30%的基础上提高15%，就要达到46%。那么所以呢，这个任务是非常的重。那么这个里头呢，也更提出了预防为主，早筛就更重要。只有早发现、早治疗，进行精准的医疗，实现这个生存率的目标，才可能实现。今天呢，咱们这个直播的内容，是非常好，而且我认为也符合中国的实情，就是在我们国家推行的大健康医疗改革政策，是非常有利的。那么我国的乳腺癌筛查，从刚开始的自我的触摸，到超声检查，然后到钼靶检查，最后呢，提到就是核磁共振的这个精准的检查，这个手段，技术的发展呢，为我们早筛、早发现以及制定今后的治疗方案，这个精准、科学的来进行治疗，是非常对患者来说是非常有益的，因为对它的效果、治疗效果是非常有帮助的。我们呢，我们这个组织呢，是专门支持我们那个全国的患者组织。我们现在患者组织在全国有100多个这个人，那么有40多万，其中有40多万是乳腺癌患者，所以这个里头呢，就我们觉得可以很好的一个机会来学习了解这些新技术发展。尽早的把这些新的理念、新的技术能够应用到实践中，使更多的患者能够就是在治疗和治疗方面呢，就能够更多的姐妹们能够受益。所以我们在这儿呢呼吁，就是说抗击癌症是一个非常复杂而且很就是比较那个重要的。那么它不可能一个组织一个方面的人单打独斗，所以我们呼吁医疗界我们的专家们要和我们的患者以及患者组织以及企业社会各界的同仁们，大家一起携起手来，为抗击癌症贡献我们的力量。好，我的发言就到这儿，谢谢。
Olivia, go ahead.
Yes, we will have Dr. Nick Morse to translate into English.
Well, I can read it. I can't really take credit for translating, but good morning and evening. I am Unleash from the Beijing Love Book Cancer Foundation. It's my pleasure to have the opportunity to participate in this webinar today discussing screening strategies for breast cancer. Breast cancer is one of the most common malignant tumors in Chinese women and has surpassed lung cancer to become the most common cancer in women. According to statistics, the age of breast cancer onset in the Chinese population is lower than in Western countries, the peak incidence being 45 to 55 years old, while in Western countries, the peak incidence is after 65. In China, the number of new cases in 2020 exceeded 416,000. Due to the lack of early detection, most cancers are detected late, and the 5-year survival rate of breast cancer patients with advanced stage disease is only 20%. They also bear a huge economic burden along with their families. In recent years, the state has released the Healthy China 2030 program outline and the Healthy China Action Plan, which clearly proposes the implementation of cancer prevention and control actions to achieve prevention first, early detection, early diagnosis, and early treatment. China has also introduced a series of medical reform policies. It is proposed that by 2030, the overall cancer survival rate should be increased by 15% to reach the target of 46%. Therefore, prevention is the main priority along with early screening. Only early detection, early treatment, and precision medicine can improve the survival rate. Today's live broadcast content is in line with the National Healthcare Reform Policy. Breast cancer screening in our country ranges from self-exam to ultrasound exam and mammography, and finally to precise MRI examination. Technical development of examination methods provides early screening and early detection for us, as well as formulating future treatment plans. Evidence-based and precision treatment will definitely bring good therapeutic effect to patients. We organize more than 400,000 breast cancer patients from more than 100 patient organizations across China to learn and understand new technologies and strive to apply these new technologies and new concepts in practice as soon as possible so that more patients and all women can benefit. We call on the medical community, experts and patients, as well as colleagues from enterprises in all sectors of the society to join hands and contribute to the fight against cancer. Thank you very much.
Excellent. Thank you. And well, Professor Fang, we can start the question and answer section.
Well, I need to give a list of the panelists first. We have quite a large number. From Aurora, we would have Olivia, of course, Olivia Chang, the CEO, Dr. Stephen Harms, the Chief Medical Officer, Dr. Becky Staub-Clinton, Chief Breast Radiologist, and Dr. Nick Morse, the Medical Director. Of course, we also have the Chairman of Give to China Foundation, Mr. George Sayep. We have also Dr. Adam Yang, the Chief Innovation Officer from Taiwan Veteran General Hospital. We have Dr. Jing Ma, who is the President of the US-China Health Summit. We have Chairman of the Beijing Love Book Cancer Foundation, Dr. Anli Shi. Chief Breast Surgeon, Dr. Liu Jingping from the Sichuan Provincial People's Hospital. Chairman of China Pink Ribbon Foundation, Dr. Zhang Rui. Secretary General of the same organization, Mr. Wu Hongxian. And Executive Committee member of Hong Kong's Cancer Foundation, Dr. Janice Zheng. CEO and Superintendent of Shenzhen's Luohu Medical Group, Dr. Luo Xizhou. And last but not least, from Shanghai Xinhua Hospital, breast cancer specialist and leading physician, Dr. Han Baoshan. Okay, now let's begin with the Q&A side. Olivia?
Yes, okay. We have a list of questions from the audience. Professor Ma, do you want to pick one to discuss? And then Dr. Yang pick one too.
Hello?
Okay. Yeah, I'm choosing. Okay. So let me see. Let me try.
You want to maybe start from the first one?
So actually I'm starting with let's start. Let me start the first one, and then I will answer I will choose this, another one. So the question is, let me read it. It's in English. Oriental females usually have dense breast tissues. Mammography is very uncomfortable procedures and give false results frequently. Would MRI be more suitable for Oriental females? How is the cost of MRI versus mammogram? Let me translate into Chinese. 东方女性呢，一般来说呢，都是比较有这个乳房啊都比较致密，那么用这个钼靶呢 X 线呢，在检查的时候呢是非常的不舒服，而且呢还正如这个 Dr. Hollingsworth 提出来的，他还给出很多的这种假阳性或者是这个假阴性，那么听起来呢 MRI 对于东方女性是更加的适合，但是它的这个 cost， 它的这个它和钼靶比，它们的这个价格又如何呢？ So Alan, could you please answer the question? At least in the US.
Yeah, well, the cost is interesting. Ultrasound is higher than people realize. MRI can be lower, but we have $500 and $600 cost of them for ultrasound. We made that more affordable by having a whole breast ultrasound machine, but that program didn't work so well. Right now, the cost varies a lot depending on the hospital, but I think the future is going to have decreasing costs with MRI. And of course, if the non-contrast MRI works out, the costs are going to go way down. But you have some hospitals that will do MRI screening for roughly the same as ultrasound. It becomes more of a question, what do you want, what's best? And the short answer, MRI is better, but at the same time, if you want an immediate answer, especially in countries that don't have the infrastructure, and you wanted immediate help with your dense mammograms, you just go right in for ultrasound until the MRI infrastructure gets built up. But the other thing is, in my practice, I didn't do either or. I had a lot of patients that I would say do MRI on every 3 years, but did ultrasound on the off years. And that was largely economics, trying to keep things as inexpensive as possible. It was also trying to minimize gadolinium when you're talking about screening somebody for 40 years. So it's not always either or. I think you can combine the two, but always remember that the MRI sensitivity is way higher than ultrasound.
Okay, so
Becky,
let me, Becky, do you have some comments? Dr. Becky 也是一个是专门做影像的医生，Hollingsworth 是外科医生 ，Becky 是影像医生，所以他们两个是非常 close 的同事，一起发表了很多的文章。Okay, Becky.
Well, there's not any question that mammography is not as effective in the Asian population because their breasts are so dense and mammography is uncomfortable. And I think that my understanding is that a lot of Asian women are having whole breast ultrasound instead of mammography as their first screening, as their screening modality. So that makes the most sense right now financially until the MRI becomes more widely available. But if they are at increased risk, certainly the MRI in the Asian population should become much more available, and with the artificial intelligence being able to do it without contrast would make it cost effective. So are you going to translate that?
Yeah, I will. Yeah, that's Becky 的回答非常的这个她对中国还是很了解。她说中国的女性呢，大部分都是通常用的超声来做筛查。那确确实实是全国的项目，或者是甚至这个体检中心在做乳腺癌的筛查的时候都是用的超声，这个是make sense， 就是确确实实因为它的这个价格比较低，而且在中国是非常的常见。那么这并不等于说我们不要考虑 MRI， 因为 MRI 更加的灵敏。那么同时呢，如果对于这个高风险的人群，这个致命性的乳房呢，MRI 也是一个非常值得考虑的一个筛查的一个至少进一步的诊断和筛查的这个手段。那么尤其是如果刚才提到了如果在这个非这个注射剂的不用使用注射剂的情况下的这个 MRI 这个核磁的人工智能的这个技术能够得到进一步的开发的话，那真是开阔了一个非常广阔的前景，它会极大的降低它的这个成本，那么同时呢，缩短它的时间，也节省了它整个的效率。那如果这个能够成功的话呢，对于我们在东方女性当中做乳腺用 MRI 非超引剂的这样的一个显影剂的这样的一个 MRI 核磁来做乳腺癌的筛查呢，是非常有巨大的潜力和广阔的前景。那这里呢，我要给大家再补充一下呢，刚才我作为第一个提问者哈，那我自己也谈一点我的自己的感想。那我是作为一个肿瘤流行病学的这个researcher 一个研究者，那么同时呢，也是作为一个中美健康峰会的主席兼秘书长，也是 Olivia 也是我们的这个中美健康峰会的理事。那么我们在一起并肩这个做这个中美的这种在健康领域里的交流也有近10年的这样的经历。那今天呢是一个非常非常好的一个展示呢，就是一个 typical 的一个example the multi-country exchange of research, clinical experiences, and new advanced technologies. 就是我们现在在科技、医疗、科技领域里的这种多国的这样的一个交流，多地区、多国家的交流，是一个非常好的一个尤其是现在在疫情当前大家都不太容易走动的情况下，那么我们在线上在这样的一个多地甚至你们在美国也是在很多不同的地方，所以 very effective 非常有效的这样的一个交流，非常高兴有很多的老朋友又在线上见面，那么同时呢我作为一个 researcher I should say this is the fantastic lecture. I have been teaching epidemiology and screening is one of my lectures for Tsinghua students. And Alan, you give the best lecture. If you permit, I would like to use your video to show my students. This is so comprehensive and so thorough. You talk about the history and you talk about the different technologies and every single ones are evidence-based for over past several decades up to now. And we can see not only MRI, but also mammography, ultrasound. What's the history of breast cancer screening? And what's the pro and cons of breast cancer screening? You really cleared up many confusions for people in the history of breast cancer screening. And this is truly, thank you for this wonderful lecture. This is truly a fantastic lecture following last year's Stephen Harm's first lecture of Lawlenberg. I'm so be part of the commentator. 所以我刚才用英文表达了我对这次讲座的这种深刻的印象。那么我作为中美健康峰会的主席兼秘书长，特别的感激 Olivia 组织了这样的一个多国的多地区的他们在美国也是很多的不同的地区这样的一个非常有深度又非常有意义的一个讲座。那么同时呢，我作为一个研究者，我在清华也在上这个流行病学的课。今天这个关于肿瘤筛查，尤其是乳腺癌筛查的历史，它的技术、它的进展、它的科学研究，如此等等，给了我们这么非常有意义的，而且是非常棒的一次课。我相信Alan 的今天的这堂课呀，今后我会反复的在清华用谢谢 Alan。
我想时间的关系，可能我们顶多再一个问题吧。
杨主任还在吗？
有在。
一个问题，对。
那我觉得我们应该可以回答那个有一个他说多长时间要做一次核磁共振比较安全，这是比较就是科普的一个问题，我觉得还蛮重要的。我想来回答这个问题，不知道好不好？
好，
呀，那个先 translate 一下这个问题就是 How often is it safe to have MRI scanning 那这个 OK， 这多久做一次 MRI 的一个筛查比较安全那基本上到目前为止，并没有很强烈的证据来表现有很明显的风险，这表示说这个磁共振是目前最安全的医疗的程序之一但是有一些情况下面可能不建议做 MRI、BMI 就是一些扫描，比如说如果你在身体里面有一个金属植入物一个心脏的一个起搏器或者是人工关节，事实上是比较不行做这个磁共振的那通常在怀孕的时候呢，也不建议做磁共振那我们用英文来讲，就是 No evidence has been found to suggest there is a risk for MRI or breast MRI, which means MRI scans are one of the safest medical procedures available. But MRI scans may not be able to recommend in certain situations. For example, if you have a mental implant fitted or such as a pacemaker or artificial joint, you may not be able to have an MRI scan. And there is also not usually recommended during pregnancy 那基本上一个乳房的磁共振要做多久做一次，或是多久才能去做一个乳癌的一个筛查基本上要根据你的这个就是第一次做乳腺检查以后的分数。如果你是一个比如说1分2分的一个分数的话，基本上我想1年2年大概都是一个很好的保护期。那如果说4到3分的话呢，也许6个月就要做一次这个 BMI 那如果说是4分的话呢，也许如果你不接受一个生检的话呢，那可能就要更紧密的接种这样的治疗，大概是3个月左右所以这个可能希望能够回答到这个 quiz 的问题那我们就会把这个做一个比较好的一个解释。所以这个基本上一个磁共振是一个非常安全的检查，那可以放心来做，不像我们的这个钼靶检查或者是一些比较一些侵入性的东西会比较危险那而且它是没有辐射线的。但是如果说在做一个有 contrast 检查的时候，就是有对比显影剂检查的时候呢，如果肾功能不好，那的确要小心一点，就是我们会做这样评估 那最近有一些文章是说，可能有一些显影剂对于脑部的神经会有一些影响哈。但是我想我们在国内做一些这个磁共振的时候呢，这些重要的因素都会一起考虑哈，会根据病人的最佳的因素来做这样的考量啊。那英文还要再讲一次吗？还是这样就可以？
英文讲一次。
Okay. How often is it for breast MRI? It will be according to the Barrett score. If you have a Barrett score, for example, 1 or 2, then annual or biannual study will be recommended. However, if you have a Barrett score 3 or 4, it depends on your condition. Score 3 will be recommended for at least 6 months for 2 years sequentially. And if you have a Barrett 4 score, then a biopsy might be recommended. However, if you refuse to take the biopsy, then a 3 months interval might be recommended for any breast MRI abnormalities. Yeah. And since the standard MRI for breast will need to have some contrast study, so if you have a poor renal function, then we will have a detailed evaluation of your renal function to have some strong recommendation if you should receive the contrast-enhanced MRI or not. And recently we have some studies about the gadolinium deposition on the brain. So if they have strong, we call the anxiety or anxious thinking about the brain contraindication, so probably we have to shift to non-MRI as well. Yeah. 以上，谢谢。
You want to make a comment, Alan?
No, I was listening for a question and didn't hear it, but a lot had to do with the safety of gadolinium, and he's right. It's been monitored very closely, and still no evidence as long as you have good renal function. So as far as interval or high rate, we still think it's okay. But I know that in the United States, the FDA is looking at it very closely, and we have to give a little disclaimer to our patients, a little pre-printed information about it and so forth. But so far it looks safe.
Yep.
Well, thank you very much.
Dr. Fang?
Yes.
I'm very interested in one question from the audience, but myself is also very interested in.
Go ahead. This will be the last one.
Okay. So Alan mentioned about combination between MRI and the blood test, and one audience asked about this blood test is the similar to clinical blood tests. What's the stage of this test for breast cancer? And whether this is still at the same as the non-contrast MRI. Is that similar to the non-contrast MRI still in the research stage?
I don't know exactly how far along Dr. Wei is. But on the blood test, it's technically still research stage, but they have developed some clinics near them to start using it to get more data in a registry form. And so it's the thing that all biotechs suffer from. They have to show their investors that they have some income while they continue to do research on the backside. So that's still definitive research is still underway, and you can't. So I would give them one or the other. I'd have to classify it as research on the brink of becoming useful. But,
thank you.
Yeah. Okay.
Yeah. Thank you.
But Dr. Wei will have to answer how far along he is with
Dr.
the
Wei,
non-contrast.
do you want to make a comment?
I think he's muted because if you're not on the panel, then it's muted. I can answer that for him.
Okay, so Olivia, can you answer?
Sure. I think for non-contrast MRI to be commercially usable, we will have to pass FDA, and we're a year out from there.
OK， 那我来翻译一下。 简短一点，就是 Alan 和Olivia 都提到了，就是说这个非造影剂、无造影剂的MRI 呢，现在也还是在这个研究当中。那么估计大概还有离这个 FDA 的这个 approval 还有这个还有1年时间。那么 Alan 呢也是在说这个血液检测呢，也还是在研发当中。那么也希望呢能够进一步的得到投资者的这个支持，然后呢现在在临床实验两个都是非常的 exciting. So yeah, these are all very advanced technology and science, and this is what the Chinese people are waiting for, because we have 0.3 billion women are waiting for breast cancer screening. So we truly hope these new technologies and advanced science could be fast approval and show more evidence and apply to real practice. 我们就希望这一些真的非常前沿的科技的发展，无造影剂的 MRI 和我们的这个血液检测呀，能够尽快的拿到更多的实验证据，然后呢尽快得到 FDA 的认证，然后呢用在我们将近3亿的广大的这个妇女的筛查当中。好，谢谢。
Okay, I think we have come to the end of this truly exciting lecture by Alan Hollingsworth and a series of Lauderberg lecture. As the only physicist in this audience, I'm pretty sure I'm the only physicist in this audience. I have to say that how gratifying it is for me to see that what the physicists have invented have become a life-saving, literally a life-saving technology for humanities. So I am truly honored as a physicist in this operation to see that the field that I have worked for over 40 years is becoming such an important medical device. Thank you. 要翻译吗？不用翻译了啊。Okay. Well, Olivia, you want to say a few more words to end the whole thing?
Yeah, we are.
Dr. Fang, you need to show your picture.
Yeah.
Oh,
right.
Sorry.
I can't say thank enough for all our colleagues' participation in this reaching out to the world to bring the technology and the clinical evidence-based operation to greater region of the world. And thank everybody's participation, and we look forward to having a continuous dialogue and collaboration for the benefit of the all. Thank you. Thank you all.
Thank you. Thank you.
Thank you.
Thank you. Thank you, Alan, for the wonderful lecture. Thank you for Dr. Fang.
You're
For
welcome.
the wonderful host.
Thank you, Steve, for being the father of breast MRI.
Yeah. Bye-bye.
Thank you, Steve.
Yeah.
Thank you, Rebecca.
Okay. All right.
Okay.
Thank you. We will communicate with all of you with a question if it's not answered currently. 我们会让那个有你们提出问题，如果没有我们现在没有回答的，我们会那个线下跟你们回答。谢谢你们。
Okay.
All right. Thank you, everybody.
谢谢。Thank you. Bye bye.
Thank you.
Bye.
Bye.
Bye bye.
Bye bye.